we have a new system state, a new world. And that is how simple a theory of everything can be. I might note a few interesting differences between the scalar or electrostatic bit operation and the vector bit operation on the right. The electrostatic bit operation occurs only between spot cubes. If you go back and look at the spot cube diagram that I showed in the slide before, you can see that the only way to get concurrent pointing in the same direction spot units is between spot cubes. They don't occur within a spot cube. On the other hand, all of the magnetic bit operations occur with countercurrent spot units. Countercurrent means they point in different directions within a spot cube. A similarity, as we've seen, is that when everything is true for the needed ingredients, we accelerate one state m bits from the m to the l bit loci. So you're probably asking, when do we get to the hard part? Well, actually, there is no hard part. The way the universe works is very simple, as we've presented here today. Think about it. Theoretical physicists need to be very practical. You can't have like 10 or 11 different dimensions. You can't have all kind of complicated equations, which sometimes every little thing that wasn't taken into account before is another term added to an equation which nobody can really understand. That just doesn't work. That's not parsimony. That's not Occam's razor. That's not practical. If you call up a supplier and shut up. If you call up a supplier to order an infinite number of a huge number of supercomputers that are infinitely small and that can sense things like objects far away or electric charges far away and sum all that up and compute what the value of that field is instantaneously, the supplier is probably going to tell you, what are you, crazy? Is this a prank call? Or we don't have infinitely small computers. We don't do miracles here. Go talk to your priest or rabbi or guru or whoever, because you're talking about something which is sort of magic and miracles. So to sum up, we might want to cross-tabulate the four binary mechanics bit operations with a conventional force classification, which is based upon particle interactions, which is obsolete way to proceed. First, the so-called electromagnetic force is actually maps to two different bit operations in binary mechanics. Second, the so-called strong force involved in the structure of the proton maps to the strong force in binary mechanics. But the use of the word strong can be confusing here because it has a different meaning in the conventional and the binary mechanics approach. And that can be confusing to people, I suppose. But these are just words. The important thing is what the equations say. Now, the so-called weak force and neutral weak force involve the so-called plus or minus W bosons and the Z boson, crazy stuff like that, which we've shown here at Binary Mechanics Lab that the unconditional bit operation alone produces these particle interactions. So the W and Z bosons are identified as related to the right-handed matter d quarks. And by the way, there's some experimental evidence that if you look at the data and ask the right questions, you'll see that this statement I'm making is actually probably the best way to interpret that data. Whatever the theories that the experimentalists have when they gather their data, it doesn't matter. Maybe they're asking the wrong questions. You can look at their data and ask different questions, a different hypothesis, and maybe come to a better conclusion, which is more relevant. Lastly, gravity is not a primary force. Thus, quantum gravitation unification is achieved in binary mechanics. Actions of all four of the bit operations produce the gravitational phenomena. And thus, quantum gravitation unification is achieved in binary mechanics. Now, if we march along and transition from legacy physics in the 20th century and for many people up to the present to 21st century physics, in our summary table below here, unconditional bit operation does not define a force. The so-called weak force is due to the unconditional bit operation. That's how lost many contemporary particle physicists are. And we see that we have three forces defined, scalar, vector, and strong. Each of these three forces have a nice parallel of three components, a source one state locus, an adjacent locus that has the potential for that force, and a destination zero state locus to receive the incoming quanta. If binary mechanics postulates defining system state in the bit function, equations 1 to 6, and its time development, the rest of the equations are complete and correct, then they are a comprehensive physical theory which suffices to represent fully any known physical system and its dynamics over time. Any exception would imply that the postulates are incomplete or incorrect to some extent. We just talked about figure 5, which cross-tabulated the conventional classification of physical forces with the binary mechanics bit operations, highlighting several key advances. First, the purported electromagnetic force maps to two-bit operations, scalar and vector. Second, the unconditional and strong bit operations entirely account for color confinement. That's the circling of bits in the bit cycles, and other videos explain all of that. The unconditional bit operation produces so-called weak interactions, which therefore do not qualify as evidence for a fundamental force. In summary, what particle physicists have been doing, and in most cases getting nowhere, is use of supposed particle interactions to define fundamental forces, which has failed to produce clear, consistent results and lacks scientific merit. In other words, say for gravity, which is not even a force, and yet they're going to say there's some particle, let's call it a graviton, they say, let's look and find it. But they haven't found it yet. I don't think they are going to find it. If they find some data which they interpret as the graviton, they're probably going to make some other colossal mistake. I hope this walkthrough in the game of physics has been fun and enjoyable, and now you might want to join us and play the game. Take care, be happy and healthy.